The European Space Agency just released a new image of the interstellar object 3I Atlas, obtained by the JANUS camera on board the Jupiter Icy Moons Explorer, JUICE. JANUS is a multicolor optical camera designed to take high-resolution photos of Jupiter and its icy moons. This image was taken on November 6, 2025, a week after closest approach of 3I Atlas to the Sun. It displays jets coming out of the nucleus of 3I Atlas opposite to the direction of the Sun. This is surprising, since pockets of ice on the surface of a rock are supposed to be warmed up by sunlight on the sun-facing side, creating jets that are initially directed at the Sun. The JANUS image resembles images taken by amateur astronomers from Earth around the same time. These are a series of stacked RGB images of 3I Atlas at 4:10 UT on November 8, 2025. The sunward direction, opposite to the arrow in the top panel, is pointing towards the bottom left corner. They were taken by amateur astronomers credited on screen. In this newly released image of the interstellar object 3I Atlas, taken from a distance of 66 million kilometers on November 6, 2025, by the JANUS camera on board ESA's JUICE mission to Jupiter. The direction of the Sun is indicated on the top left by a yellow arrow pointing straight down. The blue arrow marks the direction of motion of 3I Atlas along the 7 o'clock direction. The inset displays concentric brightness contours around the nucleus. The JANUS camera took this image from a distance of 66 million kilometers, about 172 times the Earth-Moon separation. Throughout the month of November 2025, the JUICE spacecraft used 5 of its science instruments to observe 3I Atlas, namely JANUS, MAGIS, SWI, PEP, and UVS. During the months that followed these observations, the JUICE spacecraft was on the opposite side of the Sun relative to Earth. As a result, it was using its main high-gain antenna as a heat shield and its smaller medium-gain antenna to send back data to Earth at a slower rate. The related analysis teams had to wait until last week to receive the full extent of the collected data. In total, JANUS took more than 120 images of 3I Atlas, whereas the MAGIS, UVS, and SWI obtained spectroscopic data regarding the composition of the gas plume around 3I Atlas, and PEP provided particle collection data. JUICE's navigation camera also photographed 3I Atlas, and the analysis of that data is expected to be publicly released within a month. Recent images from the Hubble Space Telescope implied that the diameter of the nucleus of 3I Atlas is 2.6 kilometers, much bigger than the interstellar objects Oumuamua and Borisov. The JUICE spacecraft is expected to arrive at Jupiter in July 2031, where it will study Jupiter's icy moons, Ganymede, Callisto, and Europa. However, 3I Atlas will arrive within 53.6 million kilometers from Jupiter as soon as March 16, 2026, as a result of its higher speed. When 3I Atlas will arrive closest to Jupiter, NASA's Juno spacecraft will be able to observe it with all its instruments, including its low-frequency radio antenna. Half a year ago, I led a paper which demonstrated that Juno could have intercepted the path of 3I Atlas if it still had most of the fuel that it started with. Congresswoman Anna Paulina Luna echoed this opportunity in an official letter that she posted online. A crash of Juno on 3I Atlas could have given us a clear close-up view of this interstellar visitor a few seconds before impact. As I told the reporter today, it does not make sense for us to chase after 3i Atlas with a new expensive mission at this time. The situation is similar to visiting a bar and noticing an interesting person. However, by the time you leave your chair, that person left the bar and you realize that a chase down the street would require a huge effort. Under these circumstances, it makes most sense to look around for other interesting people rather than to obsess about the missed opportunity. For the same reason, our best strategy following our recent encounter with the anomalies of 3i Atlas would be to wait patiently for a future opportunity of an interception mission with another interesting interstellar visitor. We will likely discover hundreds of interstellar objects this century, with the Rubin Observatory monitoring the southern sky and the Argus Array monitoring the northern sky. If one of the future interstellar objects will maneuver towards Earth without any effort required on our behalf to reach it, this particular visitor will rank at the highest alert priority of 10 on the lobe classification scale. The alarming question, as with any blind date, would be whether this dating partner is proactive because it is friendly or because it is hostile. Time will tell.